In this lecture, we'll look at the confluence of several things that we've seen in previous lectures, borrowing some developments from Roman bath architecture, some elements from Islamic architecture, and some very local conditions to create what seems on the surface like an entirely new building type, but that in fact does have these kind of forebears or these sort of ancestors in Rome and Islam, and even, as we'll see, in the local traditions in which it springs. Gothic cathedrals are in some ways the kind of paradigm of what we're looking at. They're the original kind of high-tech buildings. They achieved enormous height and incredible lightness with what by our standards today are very rudimentary materials. And I want to look at how that came about, what the specific motivating and enabling factors were, and how even though we think of them as structural achievements, they were also constructive achievements. We've looked at the kind of transformation of the Roman Empire through its construction, and by 500 AD, the Roman world was essentially split and in shambles. And all of the engineering and scientific and economic advances that had come with the so-called Pax Romana, the couple hundred years of peace under the early empire, had pretty much dissipated. Europe instead was a feudal part of the world, so it was run by local lords who ruled often with a kind of iron fist, but on a very kind of atomized level. So government was really devolved to very, very small regions, even if they were under the guise of larger emperors or larger kings. The government really functioned on a very local level, and that included not only urban life, but also building and construction. We think of these as the quote-unquote Dark Ages, but in fact, if you're a historian of science and technology, you talk about a Renaissance that occurs maybe 500 years before the Renaissance that we think of in architecture or in art history. And that is by the turn of the millennium, by about 900 or 1000 AD, there were significant technological developments in Northern Europe that allowed for much more efficient agriculture. In particular, the development of more sophisticated plows that enabled fields to be tilled in ways that were particularly productive, and the so-called three-field system or crop rotation, so that farmers weren't exhausting the soil of all of their nutrients, but they were giving the soil time to recover for 2 years after planting a crop. At the same time, there was the birth, or maybe the rebirth, of mechanical engineering. We saw inventions that had been developed in Greek and Roman times, such as the water wheel or mill construction. These come back, and they come back often in interesting ways I'll talk about here in a second. This allows these sort of small-scale industries that are often tied to the sort of regional feudal governments or economies that are run by lords, but they do allow industrial production on at least a kind of minor scale that superseded anything that had happened in the so-called Dark Ages. Other inventions, including stirrups and iron horseshoes, make transportation much easier. Horses can be used for longer distances and greater loads. And there's a gradual sort of re-urbanization that's based on the economic surplus that comes about from the agricultural revolution. So instead of feudal compartments just having to sustain themselves, they make enough extra in terms of agriculture that they can trade with other economic entities. Now, at the same time, there's a rediscovery of so-called scholarship, and this comes about in two ways. One is the sort of homegrown Christian theology that develops throughout the Middle Ages, and in part that comes about because the economic surplus allows the first things that are called universities. Universities originally are mostly scholastic or mostly theologically based, but there is a whole class of people now who spend their time thinking and writing instead of just out there in the fields. And very importantly, the spread of Islamic culture into Europe brings with it some of the developments that happen in the Islamic world, but also some of the developments that happened in the ancient world that have been lost in Europe but picked up in Islam. So as Islam spreads, particularly through southern Spain, and as we'll see through the Mediterranean, developments come back to Italy and get exported as far north as France and England. The Islamic world is really the cradle of ancient civilization. It's the entity that keeps whatever developments survived the Dark Ages alive. And crucially, there are texts such as Euclid's Geometry that survive in Islamic libraries and are translated into Latin or back into Latin by the 12th century. This works the other way as well. The Crusades, which are these infamous sort of theological raids on the Middle East, an attempt to reconquer the Bible lands for Christianity, wreak havoc, of course, on the local cultures, but also point out just how much Europe is behind in a lot of ways the lands that they're trying to conquer. And you see ideas filtering back as Crusaders, knights come back to Europe, having seen in some cases works of technology, in other cases buildings that are on a scale unimaginable in feudal Europe. The scientific revolution of the 1200s, the sort of development of the academic world into science, or what's called natural philosophy, brings with it a sort of very rudimentary scientific method and some understanding of statics. We'll have to wait another few hundred years before we get a useful theory of structural behavior. But there's the idea that you can figure things out, that you don't just have to rely maybe on ancient authority. And finally, the development of roads and the development of economies also brings with it the threat of raids or of pitched battles between feudal entities. And so you get a market for infrastructure, roads, but also for defense, forts. And these both provide a kind of space for building technology to develop. In the late Middle Ages, we start to see commercial centers develop in the form of towns. So we go from villages, which are basically slightly larger than your typical farmstead, into towns that actually have people who are disconnected from agriculture and are involved in manufacture or in trade, sometimes retail trade, that allows for economies to develop on a more sophisticated level. As these towns get richer, one of the ways that they compete with one another is showing who can build the largest church or the largest cathedral. And the church becomes not only a kind of religious object, but also becomes a civic one that reflects the ambitions of the town that builds them. France has this kind of mania for cathedral building between 1000 and 1400, and this is the engine that kind of fires the Gothic revolution in construction. At the same time as those 500 major churches are being built, over 2,500 defensive castles are built in France and England in a slightly shorter time. And the workforce, not only the designers, but also the laborers who work on these, provide the kind of enabling force that will get put to work on some of these large-scale cathedrals. Crucially, the workers develop what's called a guild system, wherein you have to apprentice, you have to train with a recognized guild to join the construction team, basically. That apprenticeship can last for a couple of years in the case of stonecutters. And what it does is it provides a way for knowledge to be both institutionalized and standardized, but also transmitted from one generation to the next. Those roads that get built in the name of trade also allow materials to go back and forth. So there is an ability now to get good stone from quarries that are further away from a construction site. But they also lead to increased economic and cultural competition. If you're able to travel a little bit, you can see what the town up the road has built, and your competitive spirit might be sparked by that. You might decide that you want to build something taller, bigger, something that puts your town on the map. The technologies of water wheels, windmills, agricultural implements gets transferred onto the job site, so we get better lifting equipment than we've had in particular. And there is, coming back from the Middle East, we get the idea that geometry can be used as technology again, that the shaping or the drawing of a cathedral form can be an important part of its design and of its testing. Some of this involves full-scale drafting, as we'll see in a little bit. Some of it involves the importation of what amount to kind of building superstitions almost, where certain proportions are thought to be kind of magical, but are also based on empirical evidence. So if you have a barrel vault that is this tall and this wide, and you know that there are structures where a wall this deep has supported that barrel vault, that gets kind of encoded into the kind of magic geometry of design. And this idea that mathematics now plays a role in building construction is one that will grow over the next few centuries. The Gothic Revolution occurs in a very specific geological area too, and that is this bed of limestone that underlays northern France and southeastern England. Limestone, as we saw when we were looking at stone, is a reasonably strong but also relatively workable material. And so the fact that it is abundant in these areas means that there's a very, very natural building culture that springs up, that builds out of it, and that comes to know it very well, comes to know its properties very well. The Gothic Revolution, we think of the Gothic cathedrals as taking lifetimes to build, and many of the construction campaigns for these did go on for 50, 60, or 100 years. But the actual kind of construction of the major Gothic monuments took place really in about a century and a half. From the sort of first proto-Gothic churches in Durham and other places to Saint Denis, which, as we'll see, is the kind of church that fires things off in France. It's really until about 1275 or 1300, those 125, 150 years, see the construction of all of these major monuments, particularly in France. And historians have divided these up, I think, with some reasonably good rationale into these four phases. And we can put a little too much stake in these, but we can see that the Gothic builders sort of solve the problem of height and light, which I'll define here in a second, in this first set of buildings. They refine that solution into a formal and visual language in the next set, so-called High Gothic. And they begin to play around with that language in the third and fourth phases, what are often called rayonnant Gothic, which is where the lightness is sort of pushed to an extreme, using a few tricks that we'll look at, and where the key features of Gothic architecture become less structural and more motifs in what are called flamboyant and decorated. Now, many architectural historians see this as a sort of morality tale, that the High Gothic buildings are somehow better or purer. What I want to make the case for is that this also shows that builders are experimenting, and that it's not only the structural behavior of the Gothic cathedral that's important, but it's also its impact on human beings, on human souls in particular, and the kind of the spiritual value or the emotional impact that these buildings have is as important programmatically as their size and their shape, the way that they handle crowds. We'll look a lot at where Gothic sort of comes from. It emerges fairly slowly in the 11th and 12th century, but it ends very quickly, and some of that is due to the Black Death, which plagues Europe for 6 years around 1350, in some cases killing up to a third of the population of a town, and simultaneously the 100 Years' War between France and England that doesn't put a complete stop to things, but certainly limits the amount of construction that both regions are able to conduct. Where does the Gothic cathedral come from? Jacques Hyman, the well-known Cambridge structural engineer and historian, wrote that the Gothic was basically an intent to take the heavy masonry that had formed the basilica churches and the major Byzantine monuments, and to replace them with walls of glass, basically the visual dissolution of the structure. And the idea behind this was twofold. One, to create a truly sublime space, right? Sublime in the sense of a space that is sort of beyond our understanding. We don't quite know what holds it up It feels, as some commentators said, or as we heard of the Hagia Sophia, that it's being held up by some supernatural force, right, or some divine force, depending on who you want to believe. But the other part of this is that the dissolution of the structure, or the refinement of the structure down to its absolute minimum, opens up huge expanses of glass. And that brings in daylight, which is important in the theology of the time. We see a lot of medieval scholasticism focused on this idea that as human beings, we're kind of imperfect. The earth is a very imperfect realm compared with the heavens, and that the only way we can understand the heavenly realms is if they're sort of shown to us by illumination. And illumination can be metaphysical. In other words, we are suddenly enlightened, right? We suddenly see what we couldn't before. And there's a metaphor in Gothic construction where the illumination of the church itself, right, the light that comes into the church itself, is something that metaphorically illuminates us as well. So the divine light that opens our soul to whatever the theology is at the time, is paralleled by the physical light that comes through the building structure. This is a common theme in many religions, but it's particularly strong in medieval Christian theology. And you see here Augustine of Hippo, one of the great early theologians, has this line, "Beauty is the splendor of truth." So when our eyes see something that's beautiful, the theology goes, that means that there is something true, right? Something that is divine that we are just seeing for the first time. And this is reflected in the way that builders of these cathedrals talk about their work. There's very little written record of them, but what we do have, in particular by Abbot Suger, who is the abbot of the Church of Saint Denis that we'll talk about here in a few minutes. Suger's whole premise for the new building is exactly this idea of providing physical light that will be a metaphor for this divine light, right? The bright is the noble work, but the nobly bright work should brighten the minds so that our minds go to the true light, which in his belief, of course, is the true light of Christianity, right? The true door. So one way to think of the Gothic church is as a kind of theological machine, right? A way to illuminate human bodies, right? Human eyeballs, but also human souls. And I think the best way to understand that is to go back and look at the masonry and timber basilica churches that we saw last week. And these we talked about as a sort of technology transfer from Roman basilicas, so taking a secular type that was used for commerce and for legal proceedings and turned into a basic audience hall for religious ceremonies. And we talked a lot about the shortcomings of these, that they tended to be dark. The acoustics were terrible. They could only span a certain distance because of the limitations of timber truss work. But they were a common type, right, used perpetually for Christian basilicas throughout Europe and the Middle East. We had talked too, though, about the Basilica of Maxentius, later the Basilica of Constantine, which took Roman bath construction, groin vaults, and relied on the kind of two-directional nature of the groin vault, not only to create that long linear nave, right, crucial to the liturgy of the particular sect, but also to create these cross axes that opened up so-called thermal windows to bring in light and air into the baths, but light into the basilica as well. Now, Viollet-le-Duc, this 19th century theorist who we'll devote a whole lecture to in a couple of weeks, points to the Basilica of Maxentius, or the Basilica of Constantine. And in this long analysis, which I will let you read on your own time, he points out that if you take the Basilica of Maxentius and basically do a sort of topological exercise to it, what you find is that as he puts it, if you take out everything that's unnecessary, right, if you reduce the basilica structure to its bare structural minimums, you transform it in a way that kind of pushes and pulls and opens things up, and leaves you with something that looks a little bit like a sort of proto-Gothic structure. You can see that the arch on the right that holds the groin vault up, or that buttresses it, gets squeezed and turned into, on the left, what we recognize as a flying buttress, right? One of the signatures of Gothic architecture. The wall I gets refined into a buttress M, and the kind of Roman niches and columns get replaced, as we'll see, by a different program of Gothic ornamentation. Now, this, I think, goes back to Darcy Thompson's idea that you can take any kind of critter you want, and by doing these sort of topological stretches, pushes, and pulls, you can show that they have these similarities, right? They may not look exactly the same if you squint at them, but all of the pieces are there, maybe in different proportions. And I think you can do a very similar thing looking at the way that the Gothic cathedral as we know it emerges from these kind of very early efforts at recreating basilicas. We talked a couple lectures ago about the Roman barrel vault and how it required thick, heavy walls to buttress it. And in the Romanesque era, the Byzantine era, the barrel vault is used frequently. The Abbey Church at Cluny, which was one of the earliest scholastic or sort of proto-academic churches, used precisely this. The church is long since gone, but you can see in this reconstruction that it made an effort at bridging its nave with a solid barrel vault, supported, as you can see, by heavy buttressing walls on either side. Some of these churches survive. These are two churches in France from the 11th and 12th century, and one in Lisbon, Portugal, from the 12th, 13th century. And you can see that these barrel vaults work, right? They certainly span the space successfully. They are not overly reliable, right? You can see that they're flattening out. They've pushed their buttressing walls and they've changed shape. They have certainly developed some of the hinges that we talked about. And you can see in Vézelay in the center, a large crack down the center of the nave. Not a sign of structural instability, but probably something a little bit worrying. Maybe more importantly, you get a sense, particularly in Lisbon, that having to bring the barrel vault down on both sides of the nave gives you fewer opportunities for daylight. And while these are reasonably bright interiors, they don't have the kind of overwhelming power that the light that comes in through a Gothic cathedral will have. The groin vault, by comparison, opens up a huge amount of territory. You don't need the buttressing walls. You have a taller area that you can use for daylight. And when you line these up, as in the Basilica of Maxentius, as we saw, you get the opportunity for more light from above, but you also have more freedom to deal with the walls below, right? More of those can be turned into glass as well. So the Romans provide one half of the kind of key Gothic formula, right? The groin vault set in series to create both the nave and these cross axes that will enable light to come in. And in the next piece of the lecture, we'll look at the other piece of the puzzle, which comes from the Islamic world and sort of supercharges the groin vault to give us the recognizable Gothic module that we'll see in use for the next 150 years.